Hello guys, welcome back to another video. Today we're gonna do something a little bit special. We're not gonna do a tutorial like usual or something kind of guided. Instead, we're gonna discover together the concept of detections and the concept of protection detection to be specific, by implementing some custom rules for detected easy that I'm gonna show you right now. Let me just open up a browser. I've got Vivaldi browser right here, and we're gonna use that. Let me just move it to the other screen. Yep. So yeah, anyway, so here's my YouTube channel. I have no idea why it just opened this page, but it's a nice reminder. It's a nice random reminder to subscribe and like some of the videos. I'm not signed in, so I can't subscribe to myself, but you can do that for me. Anyway, so let me show you Detect It Easy really quick. Detect It Easy. Let's go. Start page. Okay. Detect It Easy. Program for determining types of files for Windows, Linux, and Mac OS. This is a really famous program. This is a really famous tool or toolkit that is full of small tools like this hex editor, for example, strings, visualization, and all sorts of stuff. But it's basically used and mostly used to detect specific protections and detect specific signatures inside of files and binaries. Let me give you an example. For example, this executable file right here, he has uploaded the file inside of Detected Easy, and then he got to look at some signature detections and some heuristics in here. For example, we've got obfuscation, virtualization, anti-tamper, fake sections, anti-ILDASM. I don't know what the fuck is that. Let me just Google it really quick. ILDISM. ILDIS. Come on, Vivaldi, don't make my life harder. ILDASM. ILDSM. I'm barely remembering the thing. Yeah, IL disassembler. It's apparently disassembler for .NET exactly. Lightweight cross-platform IL disassembler tool built in C#, of course, because .NET is heavily built on C#. So let me just close this. So this is an anti-disassembly, some sort of protection or some sort of trick that he's using inside of his binary or executable in here. Now we're not gonna do any of these protection sorts of stuff that are mainly oriented towards binaries, towards executables. Instead, we're gonna focus on the mobile side of things. And let me start by downloading this really quick. This Detected Easy from the releases. Let me look for a download link or something in here. Installation, install via package managers. Oh, perfect. So we can install that from Microsoft Store directly or from Chocolately. Let me use Chocolately to accept, understand. Anyways, add to script builder. Oh, okay, so here's the installation command. Let me just open up a terminal, and we're gonna install this, and we're gonna figure out where did Chocolately install our DiE tool, and then we're gonna look at the rules for detection. So let me do this. Choco install, yes. I have no idea why this always shows that a pending system reboot request has been detected. Apparently it's a bug or something, but anyway, we're downloading a package from source. Apparently we're gonna compile it on our own. I'm not sure about that. I don't really use Chocolately most of the time, but I didn't really want to well, actually, it's not that I didn't want to download an executable from here, it's just that I didn't find one. And I'm sure there is one in here that you can use. Install via package managers. Well, here in the Windows installation section, they don't provide an executable, but I remember it being somewhere in here. Current database, beta. Well, actually, it isn't. But let me just search Google for the executable. And in fact, it's not in here, but anyway, let me look at my terminal and it's still downloading. Well, it's just downloaded it and we can see plenty of errors in here. I have no idea why these errors. DiE package files install failed to exit code 1 was not successful. Yeah, I can see that. DiE not installed. This is try 3 tries. Oh, libbed is denied. Apparently I should have used sudo when installing this, so let me try this. Sudo same command, enter, yes, and go. Now if you didn't know, Microsoft Windows actually provides a, let me just run this script. Yes, Microsoft Windows provides a sudo command in the settings. If you go here, Windows I, open the settings window, let me show it to you. I think it's somewhere in here, advanced, yep. And you can enable sudo in here. Enable sudo, enable the sudo command. Running the sudo command could expose your device and personal data to security risks. Personal data is already being gathered by Microsoft, so it's not really that big of an issue, but security problems, I'm not sure about that. And yep, so the problem was basically that we didn't use sudo. We could have also run this command in a privileged terminal, in a privileged command line, but we did the same thing anyway. So in here, extracting 64-bit, chocolately libtools, DiE, and yeah, so apparently this is the directory where DiE is located, and we can go in there by using our explorer. So explore this directory and let's have a look. Now actually, yeah, well, no, actually no, we don't have an executable here, but if we go have a look at the tools folder, yeah, so basically this is our our exported directory of DiE. We should have installed a zip folder using this portable thing in here. They apparently don't provide an installer, but this portable folder should have existed somewhere in the GitHub repository in here. But anyway, we have achieved our goal, which is installing DiE, and that was pretty fast, pretty easy. And now we should be good. We have this folder that says tools, and we have this DiE.exe executable in here. Let me just launch it really quick. And yeah, this is detected easy version 3.1.0. Now the point of this video is based on the title that I haven't really thought about yet, but it's gonna probably be something like, let's implement custom detected easy rules or something like this. Now the point is to implement our own signatures that are gonna allow us to detect some custom stuff inside of APK files, and then based on that, it's gonna make our life much easier by saving us a lot of time instead of looking for certain RASP or certain protections instead of applications. Android application, we're gonna just throw our APK file to detect it easy, and then it's gonna show us all of the protections and all of the stuff that we are going to think about when solving CTF challenges or when doing reverse engineering in general. So first of all, we are going to try something generic, and we are going to throw in an APK file of a reverse engineering challenge. So I've got actually, let me just move to my DiE directory and then cd YouTube as usual, ls, and yeah, so I've got this package in here I've got this APK, and I think also we should install some of the other challenges. We should install 4 challenges of the reverse engineering. So let me grab them really quick from my YouTube channel. I still have the link somewhere in here. I think it's in the first video in the comments.
Hello there everyone, welcome back to another.
Yeah, hello there friend. Anyway, so let me, okay, why is it asking for network access? Vivaldi is really weird, man. Let me just allow it. It's is from Switzerland, so of course we're gonna allow it. We have full faith and full trust to the Swiss people. Downloads, and I'm gonna save as. Wait, what? Okay, so let me just go to DiE. Here's my Euro Truck Simulator mode. This is one of my favorite cars, but that's not the point of the video. Let me just move to my YouTube directory and save this thing in here. But the good thing is that Vivaldi has already started downloading the thing even before I selected a directory for it to unpack it, or select the directory for it to download it, which is a good thing. That's really smart. It doesn't waste your time by waiting for you to choose a directory. And we are gonna launch another Explorer instance in here, the YouTube folder, and we're gonna unpack or unzip these mobile reversing challenges. So let me just use nano-zip really quick, and they have been extracted. Okay, perfect. Now, as you remember, or you should remember if you have watched the videos, if you haven't, go watch them really quick now. Let me just close this. In this video right here, which is bypassing free RASP or Android, we have talked about RASP in general, which I did actually make a mistake. I said that RASP is a runtime application security protection or performance, but the actual thing, or the actual acronym, is this. Let me just look for it. RASP, okay, RASP, runtime application self-protection. So that's actually the correct name of RASP solutions, but it's not always about the name. It's about the functionality. And yeah, so let me just throw free shop at this to demonstrate to you that we actually have some sort of protection, or to demonstrate to you how detected easy would work on a normal APK file, and what are the standard detections or standard definition that it would give us, and what's next. Like what would we do in this video that's going to improve this normal detection in here. Like I've shown you, and I'm gonna show you again, and we're gonna keep this picture as a reference for us in this video. We want to implement some sort of signature detection for certain protectors or certain RASPs, runtime application self-protections, to help us with the detection of these tools, so that when we're playing a CTF or when we're doing like normal reverse engineering, instead of going to JADX and then searching for RASP, we can just throw our APK file into this, and it's gonna give us the detections or the protections. Now I have launched JADX in here really quick, and I'm gonna throw free sharp.apk in here, which as usual, it's an APK file, a CTF challenge that implements runtime application self-protection using this library, which is called libsecurity.so, which is actually a free RASP native library. Let me do this, and then if we look for RASP in here, we are gonna see this free RASP .sec stuff in here. So the point of this video is to make or automate this part, or this step of searching for text in here inside of JADX and finding out these security protections. Now after we do this, after we implement our custom rules inside of DiE, we can automate also the process even further and make plenty of rules for plenty of RASP solutions that we can find online, because most of the RASP solutions would have a specific signature or certain like tell or certain hint that they're going to keep inside of the APK. For example, here in FreeRasp, we can see this talsec.app/freerasp+methods string. So it can be like very easy if we just, let me just open up WSL and we can run a strings command to see if we can see this talsec or FreeRasp strings. We can make it very simple, or we can make it very complicated. And by complicated, I mean that we can disassemble the program inside of DeX, because DeX is going to do its own disassembly in here once you put in or plug in your APK file, and it's gonna detect or launch its rule-based detections. Or you can just do the easier approach, which is using the strings command. Now I'm gonna use strings, and then we're gonna choose our APK file, and then we're gonna pipe it to grep and look for FreeRasp. See if that works. Okay, and as you can see right here, we have already got plenty of detections and plenty of strings that have the word FreeRasp. Now the point of our script that we're gonna do, if we go over here to advanced and then go to signatures, yes. Now as you can see, there's no signatures in here, or apparently there is. Let me just search. Yeah, voila. So right now it's searching for signatures, as you can see in here. Apparently we had to press on this search button, and I'm not really sure what it's doing right here, or what signatures are they looking for, since this is not a executable or something, but it's looking for stuff that is usually found in executables or in binaries. However, it did detect this Rigendale thing, even though we're not on the Rigendale we're in the Rigendale CTF challenge. However, Rigendale here is a name or substitute name for, if we go and look for it, it's a substitute name for Advanced Encryption Standard. And that's my way of naming challenges. I always try to be creative with the names, so that when you Google the name of the challenge, you can find something that is going to be pretty helpful and pretty interesting. So apparently this challenge, or this FreeRasp challenge, also uses some sort of American encryption standard. And yeah, it is the case. Probably if we have some time left at the end of the video, I'm gonna show you the source code and show you the way the challenge works. And basically it just let me just go over to the video in here.
Sup guys?
Yeah, sup guys. Okay, so the challenge, yeah, so the challenge in here, as you can see, there's this encrypted flag delivered securely in memory. The challenge is basically an encrypted flag inside of the APK, and then when you purchase it, it's gonna be decrypted using American or Advanced Encryption Standard and this Rigendale thing. Now what we're gonna do is to go over here to this detected easy, and we're gonna try to work our way and implement our own detection or our own signature check. If you go here to signatures, we can get a list of signatures that detected easy is like provided with, or built-in signatures inside of detected easy. And as you can see right here, for example, this APK protector 2, for example, you get the author, you get their email and stuff like that, and then init, and then apk.isArchive record present, and after that it's gonna look for archive records. Apparently, for example, it's gonna search assets for specific bin folders, bin files, which are binary files. Also, it's gonna search libraries for this lib apkprotect.so thing, and we can start with this template in here. So if I copy this and go to this directory in here where this file exists, or these APK detections exist, and we open that inside of VS Code. So let me just go here and go to signatures. Okay, we're gonna try to find where the signatures are, and let me just look here and see if there's any of them, if there's any hints as to where these files exist. Otherwise we're gonna have to just guess where they are. Now we're gonna go back in here and look for the file name. For example, right here we have this APK protect 2, so let me just search tools for APK protect. And we get it inside of tools DB, and then we have DEX and we have APK. So based on the UI in here, we have this APK in here, and we have also this DEX thing. If you go to APK protect 2, it's gonna look for a DEX string. So apparently there is 2 ways of detecting or finding out about this APK protect. For example, it's gonna look for DEX strings. These DEX strings are the decompiled APK files or sources, and this here, APK protect 2, is also, as you said, archive record present. So let us start with this first way of doing things, which is just using this function is archive record present. So we'll go to our tools/db/apk folder. So we'll go here, db and then apk folder. Exactly, and we're gonna open that inside of VS Code. Yes, okay, let me bring it over to my second monitor. Okay, we are gonna copy this file over here. Copy, let me just hide this really quick, and we're gonna paste it over here. So paste. No, okay, anyway, we're gonna just copy this. We can just copy the file name, copy, and then we're gonna create a new file with the name of our preferred detection. So let me paste the name here, keep this extension or this SG file at the end, which I suppose means signature, and then we're gonna just rename this to FreeRasp. Unable to retry, operation not permitted. Apparently, since the file is already open in here, or detected easy is already open, we can't edit files. I'm not sure about that, so we're gonna try again. FreeRasp.to.su, and we still can't, so we're gonna try with administrator privileges, and we're gonna open this in terminal, and then we're gonna do sudo code. Okay, so updates are disabled because you are running the user scope installation of Visual Studio Code as administrator. I'm not sure what that means. If I do this and save, okay, yeah, so we can save stuff. Can you create new files? FreeRasp.to.sj, and yeah, we can create new files. Apparently we needed administrator privileges as usual. So we are gonna copy paste this code from APK protector 2. We're gonna bring it over here to our FreeRasp signature. Let me just edit these real quick. So here's my email. If you're wondering, feel free to send me hello on email. Also, here's my GitHub account. This is a really nice occasion to promote myself, and I don't have Telegram, however I have Twitter. So here's my Twitter account, just in case if you want to say hi. Now we're gonna initiate our protector with the name of FreeRasp over here, and we're gonna detect if this archive record present is we're gonna look for /lib. We're gonna remove this. Let me just hide these copilot suggestions for a second, and we're gonna go back to our free shop thing, and we are gonna look for this library, which is libsecurity.so. So we're just gonna rename this at first to libsecurity. security.so, and we're gonna make sure it's over here and being detected for all sorts of APIs. So let me do this, and let me just do this. So let me place this with x86 64. Over here we have this ARM API v7a, and here we need ARM 64 v8a. So ARM 64 v8a. Let me just make sure that is the correct name. Yeah, that's actually the correct name. So just gonna rename all of these libraries over here and we should be good. So show type, show version, show options, be detected, and the result is going to be the type, the version, and the options. Now over here I'm pretty sure that the type is this protector thing and the version apparently is this free rasp over here, but we're not sure yet. So we're gonna open our DiE file again and see if we're actually wrong. So over here, this terminal, and yeah, so let me go up and let me just make sure this is where DiE is. So let me execute DiE and try again. Now we're gonna bring our APK file from here, this free shop file. Oh, this is actually a new feature, and more option, move to folder. Yeah, but it's not really useful. It could have been something like drop this file in here and then bring it back over here, so that you don't have to do this this old-fashioned way of doing things, but Microsoft is just too dumb to implement that. We all know that. And if you look here, we don't really notice any other protector other than this DEX guard. Let us just try with signature. Look to detect it easy. Is processing, and there we go. We have our free rasp being detected with our package. However, the question is, why didn't it show up in here? Why didn't it show up in this this archive records, this thing over here? Now that might be because this detection is a DEX detection, like it looks for this classes.dex. However, when you look in here in the signatures, it's gonna perform a decompilation. It's gonna perform a really quick decompilation of the APK file, and then it's gonna look inside of the APK file, as we can see in here. If you go back over here, and as you can see, this archive record present function apparently is going to decompile the file or export it or extract it really quick, and then it's gonna look at the files inside of our APK archive. However, this DEX detection apparently is gonna be shown in here in this main UI, this main window, once we throw in our APK file. So we need to try to implement a DEX signature thing like here and see if it's gonna work. So for example, APK protect 2 as usual is DEX string present APK protect. We are going to use this one over here, and let us just close this one over here, go back to tools, and I'm gonna go to the database as usual, but instead of going inside of the APK folder, which is this one, we're gonna jump inside of this DEX folder. So I'm gonna do DEX and then sudo code just like before, and we are going to try to implement our own protector detection. Now I'm not really sure if FreeRasp is the only Rasp that embeds this libsecurity.so function or this libsecurity.so library in here. So it's not really very precise to, for example, to contribute this to the GitHub repository and make it available for everyone, since we're not really sure that FreeRasp is the only protector that does the trick that way. However, if we do this second trick over here, I'm not sure why VS Code is still in the APK directory, even that we launched it in here. Let me just check if we have any other windows. No, actually we don't. And it's still in this APK folder, so let me just open folder and change it really quick to this dex folder. Let me select that and we should be good. Yes, I trust the authors of all files in the parent folder. Of course I trust the authors, man. Look, it's got like, how many stars do they have? 10,000 stars. Of course I trust them, man. Come on. Now we have our APK protect 2 and we are going to make a new file as usual, freerasp.2.sj, and then we're gonna copy paste this over there. And let me just really quickly bring in my APK, my credentials or my promotion from there. APK2, no, we're gonna need to go up one directory and then go for APK and then FreeRasp. Yep, exactly, so this is it. I'm gonna copy this and paste it over here. Nice, that's the first step. The second step is renaming our protector to FreeRasp. And then finally we're gonna look for this text string, which is FreeRasp, and hope that this is gonna work. So as usual, we're gonna go close detected easy again and reopen it. So cd up and DiE. That's a cool name, DiE. Yeah, that's a really cool name. Okay, bring this over here. Yes, see if it works. Okay, and it doesn't work. Yeah, it doesn't work. However, if we go to advanced over here and go to signatures, then detect it easy, we get FreeRasp over here, which is based on this APK detections that we have made. However, the dex detections don't really seem to appear anywhere. I'm not sure why. I'm not really sure why. Even though this said that this protector dex guard using this APK folder, APK scan, if we go over to select detected easy, we can see our protector FreeRasp over here working pretty fine, but apparently it didn't detect, or maybe it didn't detect this dex string FreeRasp. So we're gonna have a look. We're gonna inspire from a couple of other detection methods in here, and they all use the same function dex.isDexString present, and then this string over here. So our string, which is FreeRasp, is definitely in there, just like we've seen a second ago. If I look for rasp, it's gonna be in here, string FreeRasp, all sorts of FreeRasp strings. However, we haven't specified a full string. We have just specified a smaller string or a substring, which is FreeRasp. So we're gonna try to copy this whole string over here, talsec.app.freerasp/events, and we're gonna try to search for that. So if I replace this in here and we start our signatures detections again to see if that works. So it's apparently crashing because I have edited the files while it's running. So I guess I'm gonna have to kill that. Yeah, it's not responding, so I'll just kill it. Okay, end task. I'm sorry, man. By the way, this end task is also part of the advanced settings in Windows that I've shown you earlier. But now I guess I have to start the event, and we're gonna load our APK again, okay, and see if we get our detection working. So our detection is still not working, and that's pretty bad sign. Now that we're 35 minutes in, I'm not really sure why, but if you go over to detect it easy in here, wait for this process. Now, as you can see, our detection is working twice, not only once. So the string detection in here, apparently we had to give it or to pass in the whole string, this string that you've seen earlier in the JADEX telsec.app/freerasp/events. That's actually an endpoint that's used by the FreeRasp to send events that happen on the device or events that are related to the security or the runtime application security of your app, and that's gonna send them to this specific endpoint that's gonna store a lot of that information on their server, and then the app developer gets to have a look at the statistics of these events. I'm gonna also show you that later in a second. I'm gonna show you the statistics of this very app, this free shop app that I have given to you guys during the CTF, and all of your devices have been sending a lot of telemetry data to this server, and then I get to see all of those. So let me just open up my browser really quick over here. Let me just go over to that specific endpoint, since we're already discussing that point right now. So let me just log in really quick, and I'm gonna show you guys what this means. So I'll do this, then FreeRasp apps, okay, and yeah, so this is the Telsec dashboard, and as you can see right here, I've got this geo.darkesthour.freeshop app in here. If I go to my dashboard, as you can see, I can see that 30 devices have installed the app during the CTF, and we can get to have a look at some detections or some events that happens. For example, if I go over to this activity log, we can see that this device ID, for example, at this specific date, which is the date of the CTF. No, actually this is the date I was recording the video, and yeah, so these Samsung devices, we've got Vivo, we've got Google, which is most likely an emulator. This SDKG phone, definitely an emulator, however this is apparently a real device. And you can also see the specific detections or the alerts that have been triggered and pushed to this endpoint over here to the developer. ADB enabled unofficial store, root or jailbreak. We can also have a look at this device info, operating system Android, last seen to 20th of February, today is 27th, and yeah, so this is what I was talking about. So our approach of looking for this specific string inside of the DEX, the decompiled assets in here, just worked, and we have detected FreeRasp successfully, so that's a win, and also keep in mind that this specific string may or may not be there, so I'm sure there is better alternatives to detecting FreeRasp in here. And this protector script, also this APK one, instead of this DEX one, we have also this this is archive record present, which looks for this libsecurity.so folder, this library. It's also working, and it's detecting FreeRasp successfully as a protector. So we have achieved our goal. I'm just not sure why it doesn't appear in here. If I choose my scan to detect it easy, for example, will it appear? Yeah, so if I set the scan to detect it easy over here, I can see the protector and the rules that I have just shown you guys how to develop are being triggered in here and working pretty successfully, so we can even contribute them to the directory over here in GitHub. If you feel like implementing some more detections, as you can see, this MSVC 2026 detection has been pushed 8 hours ago, which is a good sign, which means that this detected easy tool is being always developed and always getting better at detections, but it's most likely oriented towards, like as you can see over here, portable executable format for Windows and Linux, as you can see here, MSVC for example, and stuff like that. But also it supports APKs and IPA files, which are iOS application packages. So if you feel like developing some rules, please contribute them to this repository. You can always open a pull request and contribute some rules. Just make sure to be 100% sure that your rule is not gonna trigger false positives, since I've told you over here this this lib, where is it? This, yeah, well, definitely is in here. Yep, this this rule or this detection for the libsecurity.so binary is not gonna be 100% accurate. Let me just look for libsecurity.so on the internet. Apparently there is this SO domain. Well, that's really cool. I didn't know that, but I'm more interested in searching for it. And if you go over here, we can see this Android security libsecurity.so file in this repository. So yeah, so this is an older repository. It's not really something to think about or something to keep in mind. However, if we go look at this article, analyzing APK defense mechanisms against root detection, hooking, and debugging. Let's see if this guy is talking about FreeRasp. And okay, way harder, Shadex GUI, and bypassing ADB detection. That's interesting. Bypassing root security, removing security assets. Apparently he removed this libsecurity.so file, but what we're looking for is if that specific library is a FreeRasp library, and you don't really get to know in this specific article. However, in this issue over here on github.com/FreeRasp Android, libsecurity.so not found, which is good. So yeah, let's just, we can always edit this. For example, we can edit this FreeRasp 100% sure, for example, and we can edit the other one, the APK detection, based on the library's name to be like 50% sure or unsure, something like that. And that's the approach, that's the idea behind this video. I hope you really liked it. I find this sort of implementation of specific signatures really interesting, a really interesting idea, or a really interesting concept, since by implementing a lot of these signatures, you get to start to assemble your own arsenal of tools, your own arsenal of signatures. That's gonna make your life much easier when working with plenty of other detections for plenty of other protections, when reversing all sorts of APK files and all sorts of more advanced securities inside of different applications. I really hope that you liked the video. I really hope that you have learned something. That's like the whole point of this sort of thing. And also, please let me know if you like this newer approach of doing things like without a plan, just searching for stuff online, doing it on a random note, on a more chaotic sort of thing. Leave a comment, always subscribe, like the video, and share it with your friends, or share it with enthusiasts that are gonna find this interesting. Other than that, I'm really excited to see you in the next video. Good night.